Hello, Assalamualaikum. My name is Muhammad Fitri, and right now I'm gonna present to you my task for today, which is the first task is Washer algorithm. So basically, in this algorithm, we have vertices and nodes, and in this case, we have 4 nodes, which is 1, 2, and 3. And then first of all, we need to plot all the nodes in the matrices, and then if the node have a direct direction to the other nodes, we put the value in the table is 1. For example, 1 does not have direct direction to itself, so we put 0, and 1 to 2 does not have direct direction, so we just simply put 0, and 1 to 3, 1 have direct direction to the 3, and then we put 1 for the value in the table. So we fill all the table until the last node, which is the node 4. And then for the R1 is mean that we make the nodes 1 as a middle for the other nodes to arrive to the other nodes. So for example, in this case, we put 1 in the middle, so we can see 2 can go to the node 3 by through the node 1. So if they have direction to use 1 to go to the other node, so in the table we put 1 in its matrices, which is 2 and 3. We put 1 in on its value. So in this case, it only have one condition to arrive. And then for the node 2 in the middle, so we can see 4 can go to the 1 through node 2, and also 4 can go to the node 3 by using node 2, and then 4 can go within itself by using 2 in the middle, so 4 to 2, 2 to 4. So for the value, we just put 1 in the table. And then for 3 does not have any node can use 3 as the middle to go to the other node, because 3 already in the position of the corner of these matrices. Then we just continue until node 4, and then the value is 1. So that's all from the washer algorithm. For the floor algorithm, it's same as the washer algorithm, but the difference is the direction have its weightage attached on it. For example, 1 to 3, the direction have weightage. Instead of we put 1, we put the weightage on the direction, which is the 3. And then as you can see, 1 cannot go direct to the 2. So initially we just simplify, put the infinity at first, because we does not have the value yet, so we just simply put the infinity. So we fill it the table until the node 4. And then for D1, same as the washer, we put 1 as the middle. So we want to see if they have any direction, can use 1 as the middle to arrive to the other node. So we can see here, 4 can go to the 3 by using 1. So and then we just simplify, sum out the value of the weightage direction, which is 6 plus 3. So 6 plus 3, we get 9. And then we just replace the infinity with the actual value. So same as the 2 go to the 3. 2 can go to the 3 by using the node 1, so we just sum out the summation. 2 plus 3 is 5, and then we just simplify, continue the same process until the node 4. And then for the last answer, we can see they have no infinity value in our matrices. And then for the next is LCF algorithm, which is in this algorithm we have 2 set of alphabet, which is GXTXAYB and AGGTAB. So in this algorithm, we want to see if they have any common alphabet in the 2 set, and then we can pull out the alphabet, which is it have the common value in the both set. And then first of all, we just simplify, pull out the matrices of the alphabet. So for the index 0, initially in these matrices, for the first and the second row, we just set the value as 0 because they have no alphabet in the index of 0 because the alphabet start in the index of 1. So that's why we put 0 for the first and the for the first row and the column. And then for the first row, so as we can see, they have no common alphabet, and A and G we can compare it. So the value is 0 until we reach for the 5 indices of the row. We can see, we can find the common value, which is A, and then we can simplify, put 1, and then we put 1 along the way, because as we go further we collect the alphabet. So like GX, we collecting it. We just not compare in their index, but we collecting it, we compare for the whole indices. And then we move on. So this is the value of 2 because initially we already find G, the common alphabet, so we just put 1, and then we find T, the common alphabet, so 1 plus 1 is 2. So along the way we just put 2 because the common alphabet right now is 2. And then this is A, so when we find the indices that have A, which is the common alphabet, 2 plus 1 is 3. So along the way we just put 3 because we in here the common alphabet already become 3. And then until with in the corner of the matrices, they have 4 common alphabet, so we just put 4 lah. And then at the end of the matrices, when the matrices is complete, so we need to ask ourselves where the 4 come from. So the 4 come from this up 3. So when we move up of the table, we need to pull out the alphabet so that we can know the common alphabet is B. So we pull out B. And then where this 3 come from, beside of the 3. And then this 3 come from the 2. So we move up of the table. So we pull out A, the common alphabet. And then we move until the value becomes 0. So, and then at the same time we'll pull out the alphabet, which is the common alphabet of the two set of this word. So I think that's all for me. Thank you.